Now, for number 2, let's take a look at this one. We need to decipher what our u is going to be and what is the dv going to be. All right, so we have these things on the inside of the integral. We have x, e to the 2x, and dx. We know that the dx part has to be part of the dv, so that's kind of taken care of. Now we have x and e to the 2x, so basically two other parts. What's more complicated, the x or the e to the 2x? E to the 2x. So I'm going to go ahead and make the e to the 2x part of my dv, because taking the antiderivative of that is not too bad. Right? E to the u, antiderivative of that is e to the u. So it's not very complicated. And I think it may work out if we did it the other way as well, but we're going to go ahead and let e to the 2x be our dv, and u is going to be x. So what we're going to have to do here is figure out what du is and what v is. But before I do this, I forgot to do this initially. This next part, don't write. I'm going to end up erasing it. I want to go back and say, like, if we looked at this before today's notes, what would your first instinct be on this problem? Make that u, right? U equals 2x. Again, don't write this. I meant to do this before we got started, but I forgot. I'm going to erase this in a second. But let's say we went ahead and said u is 2x, because that should be your first instinct with what we've learned in the past. Then du would have to be 2 dx. So you'd multiply both sides, or multiply the inside by 2, outside by 1/2. If we were just using regular u substitution, that would make this into our du, and this is going to be our u. Problem with that is we end up with 1/2 antiderivative x e to the u du. So we don't completely change this in terms of u, right? We can't have an x in there. No, it has to be all x or all u. It doesn't work this way. So that's why regular u substitution doesn't work for this problem, and we're using this approach instead. So sorry, I should have put that in first. But now that we see that regular substitution doesn't work, hopefully it makes a little more sense why we might be trying this one instead. But let's go ahead and finish this now. If u is x, what's du? 1 dx, right? Over here, this is a little different than normal. We are starting with dv when we want to find v, so we actually have to do the antiderivative of e to the 2x. So antiderivative e to the 2x, here we would actually be able to use regular u substitution. U would be 2x, du is 2 dx. So we can multiply the inside by 2, outside by 1/2, and we get 1/2 antiderivative e to the u du. So that one works out nicely. All right, and then antiderivative e to the u is just e to the u. So we end up with 1/2 e to the u, which is just 2x. So we figured out what our u and dv are. Then we can figure out du and v. Now we can go ahead and put it into that formula. Remember, this integral is going to equal u times v minus the antiderivative of v du. So we're just putting in those parts where they fit into this formula. So we have u times v, so it's going to be x times 1/2 e to the 2x. But we can write that as 1/2 x e to the 2x minus antiderivative of v du. So 1/2 e to the 2x times dx. So we're still left with an integral using this integration by parts. Sometimes we might be able to do this antiderivative just normally, nothing, no u substitution or anything else. Sometimes we might have to use u substitution. Sometimes we might actually have to use integration by parts again. But in this case, what's going to happen is we're going to have to use, oops, this x should be up with the 2. We're going to have to use just regular u substitution again. This 1/2, I'm going to bring that out in front because it's constant, I can do that. But we have this e to the 2x again. So since it's not just e to the x, I'm going to have to set that 2x equal to u. So similarly to what we did up here, I'm going to multiply the inside by 2, outside by 1/2. So we end up with 1/4 out in front. And then on the inside, e to the u du. So we can do the antiderivative of e to the u. That's just going to be e to the u. So we get 1/4 minus 1/4 e to the 2x. And now we can finally put in that plus c once we finish off that last integral.